All right, so let's start. I have started the screencaster thing. First, any general questions? Okay. Second reminder that some homework is due today, and grading of other homework is also due today at 6 p.m. as usual. Also, as usual, I will not actually literally collect everything at exactly 6 p.m. It'll be sometime a little bit after, and I will send an email out to the mailing list when I actually collect everything. The main thing we're going to talk about today is forking, cloning, and branching, basically some slightly more advanced operations involving Git. And then I'll also show you how to build Sage from source code, which as far as the actual work you have to do to do that, it should take you like 1 minute in your cloud project to build your own copy of Sage, and I'll show you what to type in order to do that. It's pretty straightforward. Before we do all that, though, let's go around the room and have everybody give a very quick description of what you currently plan to have your project on. So let's start right here.
Doing a 4-page paper on real dynamics.
Real dynamics.
Yes.
Cool. Like fractals and stuff.
Yeah.
No.
Yeah.
Okay. Nice. Yep.
I will do approximately 5 pages paper and collaborate with some.
On what?
Collaborate with some.
Oh, but you don't know what it will be on, or?
It will be like I will do like a program just to estimate the stock price.
Okay, so in finance. Cool.
I'll be doing also a paper, 5-page, probably about my 4-grade class.
Which is on.
Forgot about it.
Okay. So you're taking another extremely exciting class.
Yeah, I just some problem. I think maybe ring theory.
Ring theory, abstract algebra.
Yeah, abstract.
Okay, cool. It's a stupid name, abstract algebra. Okay. Yep.
I'm not actually in the class. I was just sitting in.
If you were in the class, what would you do a project on?
I had no idea.
Okay, fair enough. Yep.
I'm inside a group of 3 people, so we're doing like the analyze on when you play instrument like the sound wave, and we're using some Fourier analysis.
Nice. So Fourier transform of music. Nice. Yep. Okay. How are you planning to divide your work up?
So we know that there's already an implementation of fast Fourier transform in NumPy, so we decided that we didn't want to use that. One of us is going to implement the actual algorithm.
Cool.
And then one of us is actually going to take the data and like chop it up and like glue it together so that we actually have a periodic function to work with. And we're still trying to figure out what the last version we're going to do. Yeah.
Oh yeah, draw pictures. Nice. Somebody has to play an instrument. Get some music. Do any of you play any instruments?
Yes.
Okay. What do you play?
The guitar and the piano.
Nice. Piano should be especially good for Fourier transform. Nice. Okay. What are you going to do your project on?
I was going to fix a bug or 2 or 3 in Sage, depending on how much time I have, and then also document the whole process and kind of like write a tutorial about how to do it, so that way,
Nice.
if people like me ever want to try and do it, they have like this little reference and be like, hey, it's so easy. Now they have reference.
Cool.
I am
Right.
going to write some code that implements a Julia set function, and then maybe do a couple page paper on that with some examples.
Cool. So sort of complex dynamics and pretty pictures. I think there's if you go to if you type interact in Sage,
I saw that.
you'll find examples of this sort of thing. Yeah.
I'm
Yep.
just adding a method to the class, pilot class. I'm just
Mhm.
converting the method to that. One
Nice.
converted class.
Okay.
Very much code.
Cool.
Writing a paper on both method will go and about the problem and coding for and learning.
Okay. So you're doing a project on the game Go somehow. Okay. By the way, one of the main authors of GNU Go, which is an open source Go program, is also a big Sage developer and professor of doing representation theory at Stanford, named Dan bump. Yep. What? Sorry, what game? I couldn't hear. Hangman. Okay, so you're going to make a Sage worksheet that plays Hangman. Cool. What are you doing? What's your project going to be on?
I am doing like
Oh,
trying to
what?
do the stock size.
Okay, cool. Quantitative finance stuff.
Yeah.
Got it. A project on quantitative finance. Okay. What are you going to do?
I wanted to write a program that analyzes dynamical systems and finds fixed points in their stabilities and like tells you if it's like a saddle or a center or a node.
So are these like complex dynamicals? Like what are they mapping from and on? From the complex plane to itself, or real, or
it's just
general?
real plane
Okay, real.
with 2 or 3 systems.
Okay. All right.
A short paper proving some properties that odd perfect numbers must contain if they were to exist, and then write a small bit of code to verify the sum do really exist.
Okay. So odd perfect numbers. All right.
So I'm creating a course scheduler graphical user interface that lets user add, delete, and view their courses
How? Where?
in Python.
Okay. Does that? How will it involve math? Out of curiosity. I'm not saying it will. Just curious.
I have to create like let's say a time class
Mhm.
to make sure like the times don't be like
Okay. Interesting. All right. Course scheduler. Okay. Next.
I'm gonna try to create like a math palette, like WebAssign has, or like
Mhm.
Ultimate Office Course Assistant. So non
For inputting formulas, you mean?
inputting formulas, doing linear algebra, calculus, trigonometry, mainly
Mhm.
engaged for people that aren't good at coding or anything like that, so they can go into Sage and use Sage without knowing Python.
I see. Cool. So like a couple of be able to solve some standard problems. Do you mean like are you going to do it with like an interact or something, or mainly?
Yeah.
Okay. Cool. All right. In the back.
I'm just going into Sage probability and looking at probability distributions and various ones, and
Mhm.
it's got a decent amount in there, but I was going to add some functionality to that and kind of connect some things together that so far aren't.
Okay. You should also look at let's see, scipy.stats. Import scipy.stats because there's like probably at least 100 different distributions in there.
And then moment generating functions from
Mhm.
various.
Have you looked at scipy.stats?
Yeah.
Yeah.
I have.
Yeah, it's kind of weird because it looks really broad and comprehensive. I don't know. Last time I looked at it seriously and tried to use it, I was surprised because it seemed really slow and kind of not nearly as good as you'd think it would be based on what it said it did. But on the other hand, when I complained, it seemed like it was getting revamped. So I don't know what the current status is, but I don't know. I was a bit shocked at the quality at one point in time. But that was like in 2008 or something. So could have improved a lot. You should also look, there are a couple of relevant packages that are in SageMathCloud that don't come with every copy of Sage, but they're easy to install into Sage. And it's extremely important because there's one called stats models, I think. And it's, I think it's by far the best stats type thing for Python. And it's not a standard Sage package, but it'll definitely be in SageMathCloud. And it may do quite a lot more than I think it's really supposed to be like the successor, functionality-wise at least, to NumPy's, or to SciPy stats, and possibly vastly better. So make sure you look at this. Okay, next.
I was thinking about writing some code to parse stream data from the NIH and implementing like a sequence alignment algorithm.
Cool. There is a major, I guess, third-party package included in Sage called Biopython, which you probably want to know about because if it can't do what you just described, it would be really weird since it's supposed to do that sort of thing. So you might want to do import Biopython or just Google Biopython, you'll find it. It's supposed to do that sort of stuff. It's like Sage for Python kind of thing, at least as a Python package. So look into that. You may end up finding that a lot of the stuff you're thinking of writing is there, but then you could maybe do a tutorial showing how to use it in the notebook or something, and draw pictures and explain why it's relevant. and maybe do something better than they do or something, or worse. Yep, next.
I'm working with Evan, and
Who's Evan?
he's not here today.
Aha!
But I'm modeling, so we're working together, and last quarter we took Geometry 442, and there's a
Yep.
bunch of stuff that we didn't know how to visualize just by drawing. So
Mhm.
modeling those. So I'm working on curves of one variable,
Mhm.
and he's working on surfaces, and then we might work together to finish both of them.
Cool.
And return different plots for functions that.
So you do things like plot the twisted cubic. Does that make any sense to you?
We'll return like for the curve one variable,
Yep.
the tangent, normal, and binormal vectors
Nice.
in animate.
Cool.
So you can see it as it moves around.
Cool. Right. Wait, except for one thing, you'll be sadly disappointed at 3-dimensional animation in Sage if you want to do it. 2-dimensional animation is pretty good, but 3-dimensional sucks. Sorry, at present, today. It could be very good, but nobody's made it good yet. So, sorry. Yep.
I'm going to do some image recognition and like different methods, and then plot that up our results and what they did.
Cool. Have you found any interesting Python libraries for image recognition yet, or are you just doing stuff from using NumPy?
I've been right now just reading about all the different techniques after having been through Python.
Mhm. Okay, cool.
Spy guide algorithms for Pi and in Sage and see if I can improve the performance improvements out of it over the current.
No, well, maybe, I don't know. Maybe in certain cases. It should be very fast. Like in Sage, you can get 1,000,000 digits of pi. I guess. I don't know. I've never tried, but I think you can get a lot of digits quickly. Here, I'll show you how to get lots of digits, just in case you're one of those people. You say pi dot numerical approx. I want 100 bits, and then it gives you back. And this is computed on the fly. It's not like some table lookup. I think those are binary bits, but you can see how fast it is. Like 1,000,000 bits takes, in base 10, 1,000,000 bits. Actually, it's really in base 2, I guess. Probably takes longer to convert it to base 10. If I do stir of it, it'll convert it to base 10. Okay, well, it doesn't take longer. So it's like a second to get 1,000,000 digits of pi. Maybe you don't believe me that these have anything to do with pi, but if I do that, you'll see that those are the first few digits of pi. You seem non-phased by my confidence in the speed of this. No, they're the first 1,000,000. Well, no. I don't think this doesn't do that. But you could implement that. Yes, that would be good to do. Okay, that's even better. That's an amazing thing that you can do. It's completely different. I don't think Sage has an implementation of that. Cool. Next.
I'm gonna add stuff to the pseudo class.
Cool.
And possibly make like an interactive stuff.
Nice. Oh yeah, there isn't one, as far as I know, where you interactively enter all the entries and stuff. And then it suddenly fills in numbers.
Yeah, and like have it give you like an error code if it's like a wrong entry.
Cool.
And try to speed up current solving algorithms.
I noticed that well, never mind. It's not really relevant. Okay. There's a lot of discussion on the Sage Devel mailing list in the last 24 hours about game theory in Sage and a push to get functionality for game theory in Sage. Sudoku is a game, therefore it's relevant, but it's kind of more of an optimization thing than general game theory research. Yes.
I was gonna
Hey, I like Bloom filters. That's cool. That's the main data structure used in BUP, which is the backup system that makes the snapshots for the SageMathCloud projects. What is your interest in Bloom filters? Yeah, they are cool. The one set, if you don't know what a Bloom filter is, it's a probabilistic technique for representing a subset of a set. So you can have like an enormous set, like the set of all strings or something like that. And then you can represent a certain finite subset of that probabilistically and tell whether, with high probability, whether or not something's in your subset. pretty cool. That's the best way to describe it. They have their pros and cons, but for certain problems, they really allow you to do things that are very surprising that you wouldn't think you'd otherwise be able to do quickly. So, yep. Huh. There are hidden Markov models in Sage, by the way, so you can use those to generate sequences. What would you want to do that would be beyond that sort of thing? Well, cool. Sounds pretty fun. Good stuff. Yep. What is it? Binary what's? Binary operations. Like on bit sequences or something, or bit sets? I think there's a bit set class that Robert Miller wrote. Yeah, called bit set. You might want to look at that. I think it's some like highly optimized code for representing sets by sequences of bits. And then you can do things like, I don't know, maybe this is printing out an enormous amount. You can do things like intersection and union and stuff like that. I don't know if that's what you meant at all, though. Why is this taking so long? A bit vector. I mean, you can certainly. It has, so there's a finite field with two elements, GF2, and it has highly optimized code for doing a lot of things related to GF2, like working in Boolean algebras, so algebras that where something square is equal to itself. It has something called polybori, which is the fastest program in the world for that sort of thing. There's also extremely fast code for doing linear algebra over GF2. It's like if you have a dense matrix with 10,000 or 100,000 rows and some enormous number of columns, you can find its rank and stuff like that. This stuff's all motivated by cryptography, like things like algebraic attacks on block ciphers and stuff like that. In any case, you might want to look into this bit set. There are bit operations on integers as well. Like you can make an integer and do XOR and stuff like that. But yeah, you can, I don't know, I've never used bit set, but there exists a type called bit set, which is worth looking at, which is was motivated by combinatorics research stuff, I think. Next.
I'm writing a program to calculate stock covariances, like based on the matrix of returns in a parallel way for like big data sets.
Neat. Okay, and something I mentioned recently is that quantlib may or may not be in your copy of Sage on here. Let's see. I probably misspelled that. I mean, that has to be capitalized. I'm upgrading everything to a new version of Sage, and right now about 70% of them can import quantlib. Quantlib is an enormous, it's basically the canonical open source library for everything related to quantitative finance, and it has an insane number of different functions, so you might want to look at it. If it doesn't work, wait a day, and then restart your project server, or I guess just wait a day and it'll work. I still haven't upgraded some of the nodes at Google, but take a look at quantlib because I'm sure it does stuff like that. Maybe. NumPy is also really good though for high-dimensional covariances and stuff. Okay, so that's it. All right, anybody else? Okay. Okay, so next we're going to talk about Git, forking, cloning, and branching. And remember last time I created this project from scratch with a brand new user on GitHub with a password that we made up and put up here, which I forgot, but I left myself logged in, so it doesn't matter. And so we have this project right here. And the URL of it is github.com math480b Sage course /Gauss. So up there it says Math 480b Sage course. If you have a laptop, go there right now. I'll zoom in so it's easy to see. I think you can, so it's just Math 480b Sage course. because in a moment we're going to fork the heck out of this project. So has anybody successfully got that page to come up? Yep, some people do. Is anybody typing it in right now and they don't want me to shrink the screen? Okay, I will wait. Okay, so anybody else typing in? Math 480B Sage Course Gauss. Should be memorable. Okay, so, whoa. Huh. The voice recognition thing just picked up on me saying that. Don't know why. Okay, so I will also go to this page as a different user. So we'll see this. I'll see the same thing as you. So here it is. I'm not logged in as the user that created this project. There's no relationship between me and the user that created this project, except for the same person, but besides that, there's no relationship. When I'm looking at the project, I can see all the files. Another student in the course added this license file as a pull request. Here we are. And let me zoom out a tiny bit. There's frequently you see some code for something you want to use on GitHub or somewhere else. With GitHub, what you can do is click the little fork button, and I encourage you to do so now if you have your browser opened. And what you'll do is you'll get your own complete copy of this project, like that. And I guess I have several identities. But as me, I will fork this repository. And so now, in the click of a button almost, I have my own copy of that project. And notice the URL is different. So it's Williamstein/Gauss instead of SageMath480B. And apparently now there's 7 forks rather than 4 a minute ago. If you click on the number and you're looking at this, you can see that there's like a little diagram that explains when the forks happened, who did them, at least if there's actual divergence and so on. And there's a few things we can do. We can start editing code directly right here, or we can clone this project into a directory in SageMathCloud and start using it there and pushing and pulling as well. So let's see. Well, what I'll do first is just edit some of the code right here. And we already did this before. The main point is that, let's see, I'll just add like a comment here. So add together 2 numbers. So I'll make my little change, and then I can commit it, add a doc string, and commit changes. And now, let's go back here. So notice there's no pull requests against, let's see, mine, pull request. So notice that it remembers that, so I clicked on, if you're following along, I shouldn't have done that so quickly. So there's this thing in GitHub called pull requests. So if you make changes to somebody else's project, you might want to tell them about the changes you made. In fact, you might want to encourage them to take your changes and put them back into their project. And so pull requests, that's a way of saying, hey, I have something. And you can describe what the something is here. So here are the differences between the master of, so the very tip of Math 480B and what I've just done. And I'm going to create a pull request. So I'm going to say, hey, please consider merging what I just did. And it says William Stein wants to merge 1 commit. And so that's the pull request. It's just sitting there. It doesn't mean I haven't made any change to the other repository. I can't. They're completely different users. But I could say, hey, please consider the changes I've made. Consider pulling them into your repository. And if you're out there and you're using this, I encourage you right now to do what I just did. Make some change to this code and then create a pull request. Again, all you have to do is click on a file and edit it. Commit your change by going to the bottom and clicking commit, and then go over to pull requests and click new pull request. Okay, that's it. It's like you literally just click a little bit, maybe type something, and you've created your own clone of a Git repository, and et cetera, et cetera. So now if I go to, let's see, I'm going to go in my other browser to this and see if I've got any pull requests from anybody. And indeed I have. Notice that I have 3 pull requests that are opened. So that means 3 people, one of them me, and 2 people in this room. Brian T. Taiwan, yes, you, and EGAG. You have sent pull requests. So we have 3 pull requests just sitting here. And our code hasn't been changed yet, but they're sitting here. Also, if we click on closed, we can see the pull request that somebody sent 2 days ago, which I already clicked the button to include in my code. Okay, now going back to open, first we'll start with, hey, now there's yet another pull request. How exciting. So now we'll go into this one. I go, that looks like a great idea. And you can look at, I guess, the actual commits and see what was changed. Oops, that was not the right thing to do. This is, so you can see the actual change the person made. We can make a comment on it if we wanted to. Like line by line, you can make comments on what they've done. And you can go back, and there's also a button you can push to actually kind of accept the pull request. So let me do that. I'm going to merge the pull request. And all I have to do is just click this button. And it also tells you how you could do it on the command line. To do it on the command line, what you do is go into your SageMathCloud project, and you git pull and give a certain URL, and then it would pull the changes in there. This just does that automatically, purely inside of GitHub. Okay, so I'll merge the pull request, and I can put a comment there if I want, and I confirm it. And now, if we go back to our code, this is the code by the Math4ADB user, and in gauss.sage, you'll see that there's now that doc string. Okay, and moreover, if you look at commits, you'll see that this new commit is listed here. Of course, there's lots of other pull requests. So let's see, who should I look at next? I'll look at new fork. And so let's see what it did. It added the word fork. Woohoo! Oh man, not a fork. And then we'll merge that in. And we can just go through all the pull requests and let's see, do a crazy thing. So see what that is. Oh, you added a crazy dunder. So take that pull request. Looks like somebody else added a doc string. Let's see. Yep. Well, this might be interesting because it should maybe conflict with what we just did. It's possible that it would conflict. So pull request. Oh wait, no, I suddenly went into your project, which is not the right thing to do. Okay, so we can't automatically merge this pull request. So his pull request, he added a doc string to the same function that I added a doc string to. And so you can't just click the button to merge this pull request. The problem is there's a conflict. 2 people did something, and there's no reasonable way of resolving that conflict. And so now we really have to do something with the command line, which involves leaving GitHub, but I'll just cruise on over here. I think I made a project before. And so what I'm going to do is git pull, just to update everything with the latest code that's on GitHub. That's what this does. Notice there's an error, which is perfectly okay. The error says your local changes to the files would be overwritten by merge. So that means that we have some changes that we haven't committed yet. We haven't pushed them to GitHub. Nothing. So let's see what they are. What command should I type to figure out what I've changed from what's been committed? Diff. So you type git space diff. And it looks like there's a new line at the bottom. That's kind of pointless to worry about. I really don't want to commit it. What I'm going to do is do git checkout gauss.sage. What that will do is set my file gauss.sage to be exactly what's in my local repository, what I've already committed. And now I'm able to pull because I have no local changes. Okay, so I've now pulled in some of those things. And now I'm going to go back over here, and it says this is what I should do. I need to check out this branch and then pull. Why do I have to check? Oh, this would be to test what he's done, but what I can do is the following. I can just merge in what's in that branch. So I'll just follow these steps. So I'll just do all of them step by step. Although, okay, so what this did, it's kind of good because I wanted to show you something about branches. What this is going to do is make it so that instead of my local file, the actual ones I see when I open that file, being mine, it'll switch to being what's in that person's. Sorry for not attempting to pronounce your name. Xiaoying. Xiaoying. Okay. It's in Xiaoying's code. So notice it's not going to be right yet. I have to do the next command. So git pull. Otherwise, it doesn't know it's actually there. Uh-oh, merge failed. Great. Well, that's what we expected. Remember, there's supposed to be a merge failure. So this is the exciting part. We've followed the steps, and there's a merge failure. What that means is two people did things and they conflict with each other. And this is where, I mean, this is kind of the key thing that's different about using revision control over all the other approaches to collaborating. We don't have two, you shouldn't think of it as we have two completely different versions of this code, and now we have to go through and try to merge them by hand. That's not the way it works. I mean, more or less maybe that's secretly how it works, but it's not like that. I'm sure you've worked on things before with people where you end up with two different versions of a program, and you go, okay, let's sit down for a few hours and get them to work together. And you kind of ad hocly go through function by function and play Where's Waldo and try to figure out what's going on. And it's kind of a disaster, and you're like, there must be a better way. What this does is it will create a version of the file with little markers that tell us exactly what conflicted, and it basically gives us two options. And what we do is just edit the file to get what we want as the result. So let's open gauss.sage, which I can just do right here, file gauss.sage. Look, there's just a code here. What this means is that this was what it was in our local copy. Here's what's in the other person's. So I added this doc string, you added that doc string. They conflict. And what we need to do is edit this little thing exactly what's between the left arrows and the right arrows. Just replace that entire thing by what we think should be the correct merge. If there were changes all over the place in lots of different files, when you merge, it'll do as much as it possibly can, subject to some heuristics and some sort of like parameters that are kind of arbitrary, because it's possible to cook up weird cases where it'll say the merge worked fine, but actually it's not really correct. So watch out. But usually it's fine. People tend to just trust merging. In any case, all we have to do is just edit the code to be the merge that we really wanted, and it could be some combination of the two. When you look at the two, you might realize, hey, the correct merge isn't either one of the two. It's some combination of them. This happened to me this morning when I was merging in the latest changes from the BUP backup system. Like they made some change to some line of code, and I made some change, and the correct result is some combination of the two changes. So I had to really think about it. It wasn't just a matter of choosing one or the other, which is a really important thing to keep in mind because there are a lot of like multi-way merge tool, like graphical merge tools, where you often just like select one or the other as you go through, and that's really not. You really need to be able to edit the code as you go when you're merging. So I think that it's best to just use this approach. Okay, so here's what I'm going to do. Whatever I want. I don't have to choose one or the other. I can combine them, let's say. Okay, that's kind of silly, but I can do it. Boom. Okay, so we've edited the code, got rid of the angled brackets, made it something valid, and now when we go to the command line and do what it says, namely commit, so notice it says merge conflict, automatic merge fails, tells you exactly what to do. Fix conflicts and then commit the result. So now all we have to do is type the command to commit. Git commit -a-v. That commits everything, and the -v says, hey, I'd like to see exactly what's being committed. So you type that. It puts the commit message in for you. You don't have to type it in. It's just merge conflict. Deal with the merge conflict. Okay, you can ignore everything below, but if you want to, you can look at exactly what you're committing. And then you save it, and now we've done it. And now going back over here, merge the changes and update on GitHub. Okay, so let's do that. I'm just going to follow step by step what it says. And so locally, I should say we have, whoops, not big branch, Git branch. Locally, we now have, in our SageMathCloud project, we have 2 branches. One of them is called master. That's the one we started with. The other one's called Xiaoying Zhang master. So there are 2 different branches. And we can switch back and forth between them. So if you look at the files that are here, look at, say, the Gauss file, that's master. And notice that it only has my docstring. You can also look at the other branch, git checkout, and then we can give the other branch name. And now, let's see, git diff. It doesn't want to, there's still that. Git checkout Gauss. I think that was the editor making a change. But you can do check out the other one. The little thing it did right there, it says, please commit your changes or stash them before you switch branches. When you switch from one branch to another by saying git checkout, it literally just takes all your files in the working directory, possibly deletes them and replaces them by what they would be if you check out the other branch. So it's destructive. And so what it does is it gives you a big warning before you do that. It says, hey, instead of just deleting all your files and switching them to the other ones, let's make sure that's safe, that you've actually checked in all of your changes to some branch before making the switch. So it's just safer. There's a really cool command called stash, where you should just type git stash help, or maybe it's the other way. So git stash help or git help stash. Git help stash. Yeah, there it is. So this is a way of just taking a whole bunch of changes that you might have locally and you don't want to commit them anywhere. You can stash them, then safely do other stuff and then pull them back out later. So it's just a little bit safer, and you can kind of forget about the stash if you want as well. It's a nice little command. In any case, I won't use that. So we have this other branch, and now when we do ls or look at gauss.sage, oh, sorry, I didn't actually. Oh, right. So notice now the change that we merged in is here. So in the other branch, it's not exactly like the one you have in yours, because I've done that merge and pulled everything together. So now what I'm going to do is switch back to master, git checkout master, which is exactly what it says to do here, git checkout master. And now I'm going to merge in your changes. I have no idea what noff does, but I merge it in. And now I'm going to push them back to GitHub. Git push. I think origin master is the default, but I'll leave it in. And now I've just pushed them to GitHub. And now if we look back here, look, it did something. And if we go back and just look at the list of commits, you can see that the branch merge is done. So it was way more complicated dealing with the conflict, but it told us exactly what to do line by line in the command line, and literally doing that worked perfectly. So there you are. So you don't have to memorize a lot because it kind of tells you how to do things. So let's look back here. So let's see. Go to Gauss. Are there any pull requests left? So these are open, and there's a whole bunch that I closed. And let's see. How about contributing.md? Somebody, Grant, where are you? Grant, thank you. You've made a contributing.md file. So let's look at that. Here it is. Remember to write test your code, or else bad things will happen. Okay. Good point. So now we'll merge this pull request, which will be easy because there's no conflicts. Confirm merge. Done. Let's see. And now, are there any other pull requests? Yes, there should be one more. And This one added a link function. So let's see. That looks really, oh, notice it's 2 commits. That's a difference from any of the previous ones. So this pull request has 2 separate commits in it instead of 1. One of them made a change and the other one added a line for some reason. So we can look at each of the individual commits and see what's there. And so here's the first commit, which adds the link function. And then the second commit, I think it just added a blank line. And I guess the descriptions of the commits aren't very good. One of them just says update Gauss, and the other one says add link function. But that's okay. So now let's merge the pull request. Well, whether or not that's okay depends on your project. So for a one-off project like this that isn't doing anything important, crappy commit messages and multiple stuff like that's perfectly fine. For other projects like, say, the Linux kernel, where there's a bunch of angry people looking at it, it's really important to possibly, you would just bounce this back and say, hey, no way. Actually, just for illustration, this is a mess. Come on. So that's my Linus Torvalds impersonation. Oh, maybe I should put a swear word in. Okay. So notice oh, wait, did I already merge? Oh, great. There's also a conflict. So I'm just going to close this pull request, and I didn't merge it. So sorry to whoever I'm picking on here, but I just wanted to illustrate each of the things that can happen. All right, so that just gives you a basic idea of what goes on with using Git to do revision control with GitHub. The point is that you can have one code project in various states in a lot of different places. You can collaborate with a lot of different people. With the Linux kernel, there's over 1,000 people collaborating at once on a single source code base. Facebook evidently uses one Git repository for like 45 gigabytes of stuff, including the .git directory. But it's, I guess, the working directory is something like 8 gigabytes of code, and I don't know what else, because they don't tell you. But it's kind of shocking how big of things people do with Git. It's very code-oriented, but it's actually extremely easy to use because of things like GitHub. And then also, there's one other thing I wanted to show you as far as, oh crap. So if you create a new branch locally using the branch command, so let's say you want to experiment on some new feature or something, you might think, oh, geez, I wonder how I can push my new branch to GitHub. And I just want to illustrate something that's kind of amusing. If you just type push new branch to remote into Google, notice first that I did not use the word Git anywhere in the question. It's just kind of a generic question. However, every single answer on the first page is about Git. And they're basically a whole bunch of people telling you in great detail exactly how to solve this problem. Most questions that you could possibly have about Git, you could just type the question into Google and you'll get a page of answers to that question. So it's pretty nice. And I mean, this one's a pretty good one. So Stack Overflow's a good place. So apparently it's a common question people have. Here's exactly how you do it. People like this answer. I like this answer. And it's kind of funny because this question, you could ask the same question with the same words about other revision control systems like Mercurial, but for some reason all the hits on the first page are Git. I don't know, I feel bad because I argued for using Mercurial and Sage for years and years and argued against all the Git people that are trying to get us to switch. So now I feel I have to do my penance by pointing out that I was totally wrong. Okay. Last thing I need to show you in the remaining 4 minutes, I claim this takes like 1 or 2 minutes to actually do, and you have to wait a while, but I'm going to show you how to check out from GitHub the complete source code of Sage and then initiate building it. You'll have to leave it building for like an hour or two, but you can just open your browser later and see what happened. Okay, and anyone here with their SageMathCloud project open, I encourage them to try this. All you do is say git clone and give the repository where you can get Sage from. And by the way, that repository is just github.com/sagemath/sage. If you look at the repository, you can browse the commit history, which has over 10,000 commits. And on the bottom right, there's something which will give you a URL that you can use if you want to clone the repository. But I already have it here in the notes. So I'm going to go right here, and I'm just going to go to my top level directory in this project, and I'm going to paste in git clone and that. What this is doing is it's downloading the complete history of work we've done on Sage since 2006. So over many, many years, all the commits from the very first one are there. And it takes a little time. Come on. I forgot about the internet possibly being slow. There's a few files. And done. Okay. So now if we go into the directory that was just created called Sage, we'll see that we're in a Git repository, git log. So there's a log. That's the first commit, February 11th, 2006. It says Gonzalo Tonaria because he talked me into using a revision control system. All the work for the previous year was using tarballs and random copies. And so he checked everything in for a while every time I released anything. So it all says it's him, but it was actually me. He wasn't working on the code. So now here's what you have to type to build Sage. 4 letters, M-A-K-E. That's it. You just type make, hit return, and get a cup of coffee. That's the official directions. So it's now going to build from source about 100 different programs, all in that directory. Doesn't touch anything outside of that directory. And at the end, you have your own complete copy of Sage that you can change absolutely anything about right in that directory. Okay, so like if you want to mess with the sudoku command, then you do this, and you can literally just go into the directory with the sudoku code, change it, and you'll have your own copy of Sage without change. And in the worksheet, I have some additional directions. If you want to use worksheets, for example, that use this copy of Sage rather than the system-wide copy of Sage, you have to make a directory called bin with mkdir_bin, and then make a symbolic link like that. Once you put those 2 lines in, then whenever it starts these worksheets, they'll also use your own copy of Sage. Okay? So you'll be able to see them here. All right? So before Monday, everybody should do what I just did. It wasn't very hard. It took 1 minute. Git clone make. And then you check back. You can close your terminal or whatever. Just check back like a couple hours later and see that it's done. It should work, unless like the machine runs out of memory or crashes or something, which is not likely. Okay. I'll see you on Monday.